Okay, so 11.6 and 11.7 introduce just units of measure. We have three averages, and you've probably studied these averages before: mean, median, and mode. Mean, you remember, you add up all your numbers and divide by how many numbers you have. Median is the middle value, so the middle value can either land on a number if you had an odd number of numbers, or it'll land between two numbers if there's an even number of numbers. And then you find the midpoint by adding them together and divide by 2. That'd be your median. And then mode is the one that occurs most often. Yes, you can have more than one mode. So like this example, we had 2 modes, 3 and 5. You can also have no mode. If nothing repeats, then you would say no mode exists. Okay. The reason we have 3 averages is because you use different averages. Most people, when they read about an average in a magazine or newspaper, they assume the mean average. They add them all up and divide it. But that's not necessarily the case. If you're a realtor in Vermilion and someone was moving to Vermilion, they said, what's the average house price? You probably wouldn't want to use this mean. Because in Vermilion, we have different areas in our community where houses are really, really high or on the lower end. So those would be almost pulling your data the wrong way. If I was a realtor in Vermilion, I'd probably want to use the mode or maybe even the median. What is the middle value? What do most people pay for their houses? So I would maybe even offer the mode average to my customer and say, this is what most people are paying for a house in Vermilion, right? Or if you're a car salesman, right, and you're selling cars, you wouldn't maybe want to use this mean because you would have maybe a couple of really nice cars on your lot, some collectors, and maybe you would have some trade-ins that you just want to get rid of, and that would skew your data. So as a dealer, car dealer, you might want to use the median. This is you can advertise, my average customer pays this for their car. They walk off my lot paying this. Okay? So when you read articles in papers and newspapers, don't assume that all the averages you're reading are mean. Averages, there's 3 different types of averages because in life, companies would want to use maybe a specific average to maybe either make themselves look better or to better represent their data. Okay. All right. So let's just practice mean, median, mode first, and then we'll get into standard deviation. So look at this first example, and then we'll come back. So if I'm going to do mean, median, mode, what is the first thing I should probably do with my data here? Put it in order. Very good. You're going to want to put your numbers in order. So 16, 17, 18, 2 18s, 19, 20, 21, 22, 23, and 54. Okay. And what I like to do in statistics to double check myself, because if I miss a number, all my data is wrong. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. That's one way you can check yourself to make sure you don't forget, because that's a big deal if you forget a number. Okay, so looking here, what is the range of my numbers? Do you guys remember what a range is? What's the spread, right? When you're studying statistics and values, the first thing to kind of look at is, what's my spread here? I'm going from 16 all the way to 54. Okay, that's a pretty big spread. And the second thing I noticed just looking at my numbers is there's a big jump right here. Okay. Okay, so how do I find the mean? Very good. We have a symbol for mean. It's X bar. Okay, that's the symbol for mean. You can either use that symbol or write mean. In statistics, we use the symbol. The formula for mean is this. I'm going to teach you a new symbol today. This E-looking thing, and here it is up here in your formula too, is called the summation sign. And the summation means the sum of all your x's. You're adding up all your x's. That's what this means. The sum of all my x's divided by n, and n being the number of numbers. So this means add up all my numbers and divide by n. So if I add up all my x's, what do I get? 228, very good. And we counted how many numbers I had. It was 10. So my average would be 22.8. And you look at your numbers and that should make sense. My average is 22. Yep, that's probably about right. Median also has a symbol. It's x tilde, or you can write median. It's up to you. Median, again, is your middle value. Since I have an even number of numbers, my median is going to occur between the 5 and 6. Right here, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So what number is between 19 and 20? 19.5, yep, or you add them together, divide by 2. And then there is no symbol for mode, we just write mode. What is my mode? 18, it's the only number that occurs twice, very good. Okay, we're gonna stick with this same example, and I'm gonna show you standard deviation. Standard deviation is a value that tells you what is the spread of your data, okay? So if I know my average is this, and then I count, when I'm talking about my spread of data, you actually count by standard deviations. So if my average was 10, and my standard deviation, let me show you an example. If my average was 10, and my standard deviation was 2, right? This is how I would count. I would start with 10, and I count by standard deviations going to the right, and I count by standard deviations going to the left. See that? You always start with the mean in the middle and count 3 standard deviations both ways. That's how you use those two things together, okay? But in order to do that, we need to calculate a standard deviation. And here is your formula, and it looks kind of crazy, right? But let me explain it to you. We know what a summation sign is now. It means add them all up, right? Okay, so let's label some things. We know this is square root, that's easy. This right here, sum of x squared, what that means is you're going to square each number and add them up. Right? That's what that means. You're going to square each number and add them up. So this is my data here. Let me erase my tallies so you can see. The first thing I want to do is calculate probably the sum of x squared. So this is what I'm going to do. 16 squared plus 19 squared plus 21 squared plus 18 squared. And you keep going. That's that first value right here. You're just going to square each number and add them up. So what is that? 6,324. Okay? That's the sum of x squared. The other number I need in my standard deviation is this. And notice the difference. This has parentheses, this one doesn't. This means the sum of x quantity squared. That means you're going to add up all your x's first and then square it. So add up numbers first and then square. And the good thing about this value is you should already have the sum of x. You calculated that with your mean. So I already know the sum of x is 228. So to find the sum of x squared, I'm going to take the 228 squared, which is 51,000 what? 984. Good. Okay. And then n, we should know what n is. N is your number of data, number of numbers, right? In this case, there's 10 numbers, so n is 10. Okay. So once you have all those two numbers calculated, right, the sum of x squared and the sum of x squared, you can then put it in your formula. And this is where you're going to need to try with me here, because it takes a couple of times to how do I put it in my calculator correctly. Right? Graphing calculators are great, but you do need to know how to use operations order of operations correctly. So I'm going to have this 6,324 minus 51,984, and only this number gets divided by n. Okay, so when you're subtracting these, you're going to have parentheses around that to say this number minus this quotient. Then once you do that subtraction, then you're taking that subtraction all divided by 9, because that's 10 minus 1 is 9. And then you'll square root it. Okay, so I would go 6,324 minus parentheses 5,1,984 divided by 10 equals, divide by 9 equals, and then I can go second square root, second negative sign to recall that answer, equals 11.18. So this is my answer. My standard deviation is 11.18. Okay. So what I can do with this is I can start with the mean and I can count by 3 standard deviations both ways. That's how they work together. So let me show you how to set that up. I'm kind of running out of room here, aren't I? Let's go down here. So if I put my mean, which was 22.8, I can count 3 standard deviations to the right and 3 standard deviations to the left. Okay. So I pull out my calculator, and I start with 22.8, and I'm going to add 11.18, and it's 34.28. Oh, whoops. 22.8 plus 11.18. Thank you. 33.98. Right? And then I can do a second one. So plus 11.18 again, 45.16. And then I do it one more time. You always count 3 both ways. 56.34. Okay, so then I can go the other way. So I'm going to subtract. So 22.8 minus 11.18, 11.62. Subtract the second one, minus 11.18. Whoops. 0.44, and then you do a third one, minus 11.18, and that's negative 10.74. Okay, so here's my interval. Here's my mean, right? And I'm going from here to here. Okay, so within negative 10 to 56.34. So what does this mean? Why do we do this? You've studied outliers before. And before today, to identify an outlier, you've said, oh, this is an outlier because it's really big, or this is an outlier because it's really small. But by definition, an outlier is more than 3 standard deviations from the mean. So by taking the mean and counting 3 standard deviations, initially 54 kind of looked like an outlier, because it's really big. It's bigger than all the other numbers. I jumped from 23 to 54. So I might guess that 54 might be an outlier, but by definition it is not, because anything bigger than 56.3 is an outlier. Anything smaller than negative 10.7 is an outlier. So if a number is within 3 standard deviations within that range, it's not an outlier. It's fine. But if it's more than that third standard deviation or less than that third standard deviation, it is an outlier by definition. Second example, this will go faster since I have less explaining to do now. First step again is going to be what? Put them in order. You got to put them in order to define the median, so let's do that first. So 1, 1, 2, 3, 4, How many 5s do I have? 1, 2, 3, 4, 5, 6. And then I have a 6, a 7, an 8, a 9. Okay, and I like to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. I'm good. I didn't forget anything. Okay, so let's start with mean. Calculate the mean. So what am I going to do? I'm going to add up all my numbers. Divide by n, which is 15. So what's my mean? 4.7. And if I look at my data, 4.7 should make sense. Good. What is my median? So if I have 15 numbers, my median actually lands on a number. 1, 2, 3, 4, 5, 6, 7. There's my median. 1, 2, 3, 4, 5, 6, 7. So my median's 5. And then my mode is what? 5 also. Good. Okay. So let's do standard deviation. Okay, in order to do standard deviation, I need the sum of x squared and the sum of x squared, which I already have. This is just going to be 71 squared. So I square each number. So again, this is going to be 1 squared plus 1 squared plus 2 squared plus 3 squared and so on, which ends up being 411. And then what's 71 squared? 5,041. Okay. So to calculate standard deviation here, I would take the sum of x squared, 411, minus the sum of x squared over n, which is 15, all over n minus 1, which would be 14. Right? So you need your calculator. So again, I like to do the subtraction first, 411 minus that quotient, 5041 divided by 15, divided by 14, and then square root that, and you should get 2.31. Everybody get 2.31? Okay. So I have mean, median, mode. I have standard deviation. And then if I wanted to do my interval, I would start with my mean, which is what? 4.7. And I'm going to add 2.31. So 4.7 plus 2.31 equals plus 2.31 plus 2.31. Right? So I can say, oh, 7.01, 9.32, 11.66. Do I have anything bigger than 11.66? No. So no outlier there. Take 4.7 and subtract it. I added the wrong one there, didn't I? This should be 3. 9.32 plus 2.31. 11.63. Okay, so 4.7 minus 2.31 minus 2.31 minus 2.31. So I'd have 2.39, 0.08, and negative 2.23. Right? I always like to underline the mean to identify. So no outliers in this problem. This is one more standard deviation formula. If you looked up at the other one, this was the one with data values. This is one with frequency data values. So that means the x occurs so many times. So let's say you spun a spinner and you recorded your data, 1, 2, 3, 4, 5. You landed on 1, 10 times. You landed on 2, 7 times. You landed on 3, 20 times, and so on. That's frequency. When each data value occurs more than once, there's a frequency to it. Okay? So here's your formula. The only thing that changes is that you take each one times its frequency. So this, again, I'm going to square each x value, multiply by its frequency, and then add them up. This one, I'm taking each x times its frequency, add them all up, and then square it. Right? The order of operations, multiply first, then exponents, then add, right? Order of operations. So let's look at how to do that. So frequencies look like this. This is a frequency table. Okay, so see how this, 2 students got 0 job offers, 2 students got 1, 5 students got 3, and so on. So it tells you how many job offers and the number of students. Okay. So to do mean, median, and mode, right? To do the mean, I'm going to take the sum of each x times its frequency, divide by n. Okay, so that's what this looks like. It looks like this. I'm going to take 0 times 2 plus 1 times 2 plus 2 times 4 plus 3 times 5 plus 4 times 2. All over n, which would be the total number of students. So I add up all the frequencies, 2, 4, 8, 13, 15. And that would be my mean, which is what? So 2.2. So I can say the average number of job offers is 2.2, and if you look at your data, that makes sense, 2.2. Yep, and we had a good question. Fn is your total frequencies, right? So you add up your F's, that's going to be your N. What's going to be my median? If I have 15 numbers, what's the median? If I have 15 numbers, the median is the 8th number, right? Because 7 and 7. So what's the 8th number? Well, this is 2, 3, 4, 5, 6, 7, 8. The 8th number is a 2. See that? Because if I wanted to write out all 15 numbers, I could. There's 2 zeros. There's 2 ones. There's 4 2s, there's 5 3s, and there's 2 4s. So you could write them all out, right? The frequency formulas is just a shortcut, so you don't have to do that. Because imagine if this was like 12, 12, 14, 15, and 12. You won't want to write out all those numbers. You don't want to write out 100 numbers. Okay? So frequency is kind of a shortcut when you have tallied data. But this is what I'm doing, really. And then we could find the median, because 1, 2, 3, 4, 5, 6, 7, 8th number is here, because 7 and 7, that's my middle number. And also by looking at the table, what's my mode? What occurs the most often? What occurs 5 times? The 3. Okay. All right, so to do standard deviation, I first need to find the sum of x squared times f, which is just this, 0 squared times 2 plus 1 squared times 2 plus 2 squared times 4 plus 3 squared times 5 plus 4 squared times 2. And we already know the sum of xf squared, because that's going to be this number, which was 33 squared. So this one, if you...
Where did you get the 33 squared?
33 squared, you need this, the sum of each x times its f. That would just be the top here, 33, before you divide it by 15. And then this one's 95. So then my standard deviation is going to be what? I'm going to have 95 minus 1089 over 15 over 14, which is what? So again, I'm going to do the subtraction first. 95 minus 1089 divided by 15 divided by 14, square root it, and I get 1.26. Let's do one more frequency, and then I can show you one example where you prove an outlier. So again, mean, median, mode. My mean is going to be each x times its frequency and add them all up. So again, that's going to look like this. 1 yard has 3 trees. 5 yards have 4 trees, and so on. So I'll have 3 times 1 plus 4 times 5 plus 5 times 7, and so on, all over the sum of yards, 17, 20 yards. Okay, so let's calculate those numbers. This will be 105 over 20, 5.25. Okay. Median and mode are a little bit easier. Median is what? If there's 20 numbers, where does the median occur? Between the 10th and 11th number, right? If I have 20 numbers, my median is going to be between the 10th and 11th number. So where does the 10th number fall? So 1, 6 numbers, 13 numbers. So my median is going to be 5. And if that totally confuses you, write it out. I have 1 3, 5 4s, and 7 5s. Right? So 1 2 3 4 5 6 7 8 9 10. My median is right there between the 10th and 11th number. Okay? So if you need to write it out, that's fine. My mode is what? That's the easy one. Which one occurs most often? 5 trees. Yep. Most people have 5 trees. Standard deviation. Again, I would need to calculate the sum of x squared times f. So what's that look like? Again, it's 3 squared times 1 plus 4 squared times 5 plus 5 squared times 7, and so on. And then sum of x times f squared will just be this 105. I already calculated it. 105 squared. 585. And 105 squared is that. So my standard deviation would look like this. Square root 585 minus over 20 all over 21. Oh, yeah. I don't know why I put 21. 19, very good, n minus 1. So I'd have 585 minus 11025 divided by 20 divided by 19, square root that, and I get 1.33. So here's an example of where we're going to have an outlier, and I want to show you how to prove that. So again, the mean of my data, the mean is I add them all up, divide by n, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 numbers. So add them all up, divide by 12, and what do I get? So the sum, if I add up, the sum of x is 212. So I take 212, divide by 12, and you should get 17.67. Okay? So find the standard deviation. I then need to calculate the sum of x squared, which again means you just square each number, add it up. So 13 squared plus 14 squared plus 65 squared would be 6,206. Okay. So to calculate standard deviation, I'll do my work down here. I can do it up here. I would take 212 minus 6,206 over 12 all over 11, and I should get a standard deviation of 14.96. So identify any outliers. I need to take my mean, which is 17.67, and I'm going to add 3 standard deviations both ways. So 17.67 plus 14.96 plus 14.96 plus, oh, whoops. 14.96 plus 14.96 equals 62.55. Okay. And then I would need to subtract 3 of them. So does anyone see the easier way? I can just go minus 3 times 14.96. And I get negative 27.21. Okay, so identify any outliers would look like this. 65 is an outlier because it's greater than 62.55. That's what it would have to be written as on a test. You just can't say 65 is an outlier because it's really big. We don't do that anymore. We prove by saying it's more than 3 standard deviations from the mean. Okay. So this is going to affect the mean and standard deviation, right? If I took the outlier out, my mean would actually go down because when you have a really high outlier, that's going to pull everything up. And my standard deviation is also going to go down because then the spread of my numbers becomes less. Okay? So when you have an outlier, your standard deviation is always going to decrease. And then depending if it's a high outlier or a low outlier, your mean will either get bigger or smaller. If it's a high outlier, your mean's going to get smaller. But if it's a low outlier, your mean's going to get bigger.